Shut up! Do we have to have another quiz?
Oh, senior.
All right, what was the homework for today?
Lexical analyzer.
Okay, how'd that go?
No, pretty awesome. Except for the code that was in the
Pretty awesomely, except all of the code I had to write.
Except for the error that's in your code.
What errors in my code?
I don't know. Your code is an error, so. Yeah, look, it's even right there. See? Come on. Told you. We don't fix that.
We just changed it to.
That's not a thing.
We just changed it to mathops.
Yeah, get mathops.
Yeah, but I had to do that. A whole minute.
He wasn't able to complete the assignment.
I always give you a small bug in the code. You guys have to practice debugging. Would you rather me give you a bunch of code with a small bug in it, or rather have you write it yourself? You choose. Dave's like, it really doesn't make a difference to me. I just let my cat walk around the keys for about 3 hours, and that's what I submit.
Some more profanities came out.
The reason I have to do this is I don't like the cat. So I'm just laying on the ground being miserable. You can't go near the keyboard for days.
Yeah, the second they put iMessage onto computers, like on a Mac, now you can do iMessage on a Mac.
Right.
I've had my cats send messages to people several times. Like people I already have conversations open with.
So that booty call wasn't real?
Well, I would, except for Gracie, I wouldn't expect it to make a whole lot of sense. Gracie, she can type and stuff, but.
Save me help. Help. I'm trying the cat's body.
That was once a man.
Yeah.
All right. So we are in Source Reader, and we are writing the code for Lexical Analyzer. So what does this guy do? He reads through our linked list of tokens, which we're already collecting, wraps each one with the appropriate lexical container. That is an ID, followed by an index for identifiers, a mop for a math operator, a bop for a Boolean operator, a lit for a literal, reserved for reserved words, and type for type name. Okay? Then going back to our language reference, we wrote a bunch of things. One's called get mathops, so we can get all the ops as a string array. We get Boolean ops. We get types. Get special characters. Is literal. Okay. Now, what I would probably do is I would rewrite, well, I would add functionality into language reference to detect whether or not something is a math op, whether or not something is a Boolean op, so on and so forth. Okay? So similarly to what we did here with is literal.
Yo. Alright. So I was curious.
All right, let me lay this down for you.
I was curious if like what brackets and like parentheses were considered. I just called them reserved words, but they weren't really like in the list. I did that as well.
Yeah, they're right here.
Special characters, but that wasn't one of our things.
But they're not like math ops or.
Yeah, so those are reserved words.
Yeah. That's what I ended up doing, and I just didn't know.
So math ops are these guys. Boolean ops are these guys. Anything that's outside of that, that's not a type and that's not a literal, must be a special character. So if you want, we can say is reserved word. So we really need to leave this get special characters for now because our tokenizer uses it.
So I got rid of it, and that led to some problems. Get right back, it was all good.
Huh? All right. Actually, this is
Rid of that fine code.
this is what we'll do.
Given.
We'll actually get rid of it.
Oh, what?
Right after you said, alright, let's not.
You don't know what you're doing.
All right. So I'm highlighting this. You said don't do that. Don't cross the streams, Ray. Movie quote. What movie?
Ghostbusters.
Egon for Ghostbusters.
You know he just died? How could they? Yeah, Egon died.
Dude, Ray.
I heard he wasn't going to be in the movie, but not because he was dead.
He died
Failed to mention that.
3 weeks ago or something like that. 2 weeks ago. Yeah, not long ago.
Oh, it was last week.
Could have been.
Who?
That was like 2 weeks at least.
No, Ray. Not Ray. Egon. The guy. They talked about him in the news as the guy who directed Animal. Was it Animal House?
Animal House, Groundhog Day.
Yeah.
He wrote
Caddyshack.
Caddyshack Vacation. He helped write.
All right. So what I'm going to do here is I'm going to take our get special characters thing. I'm going to go back into Source Reader. We're going to go up to our hush. We're going to go back up to our tokenizer. And here's where we're getting our special character DLE flop thing from. So I'm just going to paste this in there. And I'm going to say dot split on spaces. All right, so that should handle our special char array. Go ahead.
Why do you still have like all the math and Boolean options?
Special char array is specifically used for tokenizing. These are all the things that we want to separate into separate tokens. I'm moving away from what I'm about to do is to answer your question. So I just put this inside of tokenize. We still need to have all those operators, all the things that we want to treat as individual tokens. We need to have them in here, correct? Okay. So inside language reference now, I'm going to get rid of get special characters and instead call this get reserved words. And get reserved words is going to be the things that are not in mathops and Boolean ops. Okay? So that means not this, not this, not this. So we basically start with a question mark. These are our reserved words as of right now. That make sense? Okay. Now we're going to go ahead and we're going to add they're called predicates. What's a predicate? Learned this in programming languages last semester.
I learned that in English.
What's a predicate? Should be a quiz. Predicate is a function that returns a Boolean true if something is true and Boolean false if something's not. So for instance, is literal would be a predicate. Takes one input and returns true if it's a literal and false if it's not. We wrote several predicates last year. So I'm going to write inside of language ref static Boolean is math op. And this guy will take in a string s as a parameter. And I'm going to return true if the guy is among this set and false otherwise. Okay? So, first thing I'm going to do is I'm going to say string array mops is equal to get math ops. That should get us all our math operators. Then for string op in mops, if op dot equals s, return true. We still survived after the minefield, return false.
I just did some epic code reuse with is literal. Because everything's exactly the same except the string.
Oh. So you wrote something like this. Is member of set. And you had this guy take in a string array set and a string s. Well, you basically did this. All right.
Way over your head.
So I'm going to put this guy at the very top, actually. All right. So this method's going to take in two parameters, a string array and an s we're going to look for in that set. Returns true if S is somewhere in that set and false otherwise. So then for mathops, we'll have static Boolean is mathop. And this guy will
You don't want to make those public.
they don't need to be public. Language reference, because if you don't put public, it's package level security. So anything within this package, which all this crap is part of the default package, is accessible. So we'll say language reference dot is member of set. What set? Language reference dot get mathops and S. And we're going to return that. So that's what we'll do for mathops. Is Boolean ops. Pass that is Boolean ops. Is type. Pass a get types. Is reserved word. Pass it our reserved words. And is literal. Well, first we need to have a static string array get literals, just so we match up to everything we've done prior to this. And we'll just return that. So then what will isLiteral do? Oh. Oh, hold on. So isLiteral will return get literals, but we need to OR this with whether or not it is a space. Isn't that what we had in our isLiterals? Literals are anything that is not a space, but is inside here, correct? So our literals in our language currently are single quote, double quote, all our digits. Do we need to look for spaces? Why did we have the special case last time for checking for, I think we were checking for spaces.
Setting variables or something like that.
Oh, these are the starters for literals. So not equal to it. So really, we need to treat as literal a little bit differently. Just to keep it consistent. Yeah, actually, the way we had it written was probably the most appropriate. We can't have a set of literals. So these were just literal starters. So we just waste our time deleting stuff and things like that for is literal. We're not going to have a section called get literals. Because literals are anything that begins with any of these things. Okay? But we also need to treat true and false as literals. Those are Boolean literals, but they don't begin with any of these things. So that we treated them as special cases. All right. So now we've added a bunch of functions here to our language reference that allows us to ask if a specific token is one of these guys. All right. So we'll go back into Source Reader. And remember, we have our lookup table, which is our symbol table, and then we also have our token stream for lexical analysis. Are we going to create a second linked list that has our lexical tokens? So we can keep our original tokens? Might that be beneficial in the future? Potentially? Yeah. Okay. So we're going to create a private linked list of type string. We're going to call these guys lex tokens. All right, and we'll make sure we initialize it inside of our constructor for Source Reader. So we're going to fill up lex tokens with all of the lexically analyzed tokens. Okay, so we're going to read through our list of tokens. So we're going to say for string token in token stream, we need to lexically analyze this token. Well, we need to check first if it's a mop, then if it's a bop, then if it's a lit. What's the difference between a literal and an identifier? An identifier is anything that's not a mop, not a bop, not a reserved word, not a type, and not a lit. It's anything that's not one of those. It would ultimately be like a variable name, right? So we're going to have the identifier as our last. That's kind of our catch-all. We'll check all the other ones first. Okay, so first we'll say if language reference dot is mathop token if we're dealing with a mathop, what do? We surround it with mop and whatever the operator is, which is the token. So we will say this dot lex tokens dot add. The string we're going to add is the string angle bracket mop colon concatenated with token concatenated with closing angle bracket. Go ahead.
Why are we using this? Why can't we just add it to the linked list? Sorry.
Well, you could. You'd have to replace the guy that's in the linked list with a new guy. Now, otherwise, your linked list will be a collection of normal tokens followed by lexed tokens. I'm just creating two separate lists. I'm leaving our list of tokens in place in case we need them later for some reason. And I'm creating a brand new linked list with all those tokens lexically analyzed.
Oh, okay, I see.
Make sense?
Yeah, I get it.
So in the end, we'll have two lists, one with unlexically analyzed tokens and one with the same tokens lexically analyzed. All right. So that's if it's a go ahead. That confuse you more with that last statement?
No, I think I understand.
You're good? Oh, I heard some mumbling. Is that just Joey?
I was probably talking to myself.
Joey isn't saying.
Okay, so if it's not a math op, let's check to see if it's a Boolean op. If it's a Boolean op, what are we going to do? We're going to add it as a bop. If it's not a bop, let's check to see if it's a reserved word. Is reserved word. And if it's a reserved word, we're going to put in reserved.
This is so much more simplistic than I did.
My solutions typically are. That's the point of you doing it for homework. Well, it's not a rip. It's it's the point of you doing it for homework, struggling with it, and coming in and seeing how it magically wasn't all that bad.
I always got it right, but I always did this roundabout.
Well, that's good. I mean, when I was a student, I did the roundabout solutions too. I mean, how many times have I written crap like this? They've only improved with time. And at some point, when I start writing worse ones, then that's when we know I've hit my peak.
So I guess you hit your peak.
I know, it's terrible. I'm still better than you.
That's it. Let's open up my submitted stuff.
No, that reminds me, that's an old Tiger Woods a quote when he was going through one of his swing changes, and he was just, things weren't clicking. He was losing all these tournaments. There was some press conference when some guy said, he's like a famous reporter, said something like, well, I mean, Tiger, you're like the worst golfer in the world now. He says, yeah, but I'm still better than you. Guy was probably a pretty decent golfer if he's like a golf analyst. Probably a single digit. Tiger probably could still beat a single digit playing left-handed. Okay, so if it's a reserved word, we'll put reserved on it. Else if it's a type, if it's a type, then we'll put type in front of it. Else if it's a lit.
Do we have to do another else if? Or can it just be else?
We can't. We need another else if because I haven't done identifiers yet. We can do the else, but for the last one, I haven't done identifiers.
Oh, I missed that one.
Okay, is literal token, and for literal, we're going to put lit in front of it. Else. This guy must be a reserved, or I'm sorry, must be an identifier. If it's an identifier, what do we do with it? We put it into our symbol list, and we have to get the position in the list where we added it. So we're going to actually write us a function, private int add symbol. This guy will take a string token as a parameter. And the first thing it's going to do is it's going to see if it already exists. Go ahead.
Oh, we already did.
We did. I think I deleted it.
Yeah, we did with the code like you said.
Was it? Well, that'd be better. That'd be very.
I
That,
used it as well.
oh, okay.
Oh, there it is. Subtoken.
No, that's not subtoken.
No, there's a table record class, or I mean, there's a lookup table class.
Yeah.
It's got a table record object that uses. And then when it adds new ones, it'll check to make sure they're not already in use.
Oh, the symbol table guy.
Yeah, I think you copied it from me.
Oh, that makes sense. Oh, there we go. See, we already wrote this. See, I was about to write another good solution. All right, so we already have a thing called what do I call it here? Symbol table. So then I don't need to write this crap. So all we need to do is we need to say this dot lex tokens dot add, and we're going to call it an ID followed by the index, right? And then we're going to say, what do they call it again? The table?
Well, your add table record method returns and actually returns.
Yeah, no, I get it. I just wanted to know. Oh, it's called symbol table. Symbol table dot add table record. We'll pass it the token. And this guy boils down to the integer, either the integer where we just added him or the integer where he had been previously added. Okay. Yeah, I was just looking for the name of that list. A very short term. Okay, so that should build that. We're going to do that for each of our tokens. Perfect. So then at the very end of that, just to print these out, I'll say for string lex in this dot lex tokens system.out.println lex. Actually, let's do this a little bit more bestest. That was for you, Joey. For int I equals 0, I is less than this dot lex tokens dot size I plus plus system.out.println this dot token stream dot get index I concatenated with little arrow dude concatenated with this dot lex tokens dot get I. Okay, so when we print all these guys out, it should show us the original token and then the lex token it became. So we can check it for accuracy. So there's a reason for keeping them in two separate lists. Now I need to I'll take out our print stuff at the end of token stream. We don't need that right now. That was just showing all our tokens. So now inside driver, what will we do? We will drive. We'll process our statement, and then we will lexically analyze. And the lexical analyzer should show us that conversion. All right, so opening curly brace became a reserved word. Int became a type. I became an identifier. Semicolon is a reserved word. Int is a type. J is an identifier. Reserved word. Float is a type. Square bracket is reserved. 100 is a literal. Square bracket is reserved. A is an identifier. Reserved. Float is a type. V is an identifier. Semicolon is reserved. Float is a type. X is an identifier. While, that's actually, oh, that's what you were asking me about earlier. Right. We don't have that in our list of reserved words. Correct. But we can because of the way we've written this, we could very easily add that, right? I mean, it would take 2 seconds to add while into our list of reserved words. So that's the advantage of writing this thing modularly like we've done it. So while right now is treated as a variable name because we haven't officially supported while loops. So it's an identifier, reserved word, true. Oh, true is a literal. That's correct. That's our special case, literal. Then we're in the Dane path of the bobsled track here. So we had a bunch of reserved words. Curly brace is reserved. Do is an identifier. I is ID 1. So we see how it looked it up correctly. Equals is a mop. I is an identifier. Plus is a mop. 1 is a literal. Semicolon is a reserved word. While is an identifier. We've already seen it once, so it's same same index. Reserve word, identifier, reserve word, identifier, reserve word, Boolean operator, identifier, reserve word, identifier, mop, ID, mop, ID, reserve word, okay? So I think that's the solution to the homework assignment. And just so we can quickly see the change that we could use here, we see we have break, we have if, we have while, we have do. Do we have a 4 in here? So I'm going to go into our language reference, and for reserved words, inside of get reserved words, I'm going to add break, while, do. You can go ahead and put a 4 in there. Anything else?
Like all of Java? Or?
No, just from our little languaging thing here. We'll just run this again and see. So now you see while is now being flagged as a reserved word just by adding it to our language reference. Do is a reserved word. There's my break. Okay. So we saw how easy it was to quickly add a reserved word. So we got some. You were snoring.
No, it wasn't.
How do you know?
I don't know, I just know.
That's why you got to sit over here so I can wake it up and fall asleep.
Okay. Questions about that? All right. So next step then would be our tree structure. And our tree structure has a look ahead. The good news is I won't give you that assignment today. I'll probably just give it to you over the weekend. Which is preferred? We're not going to be ready to give it to you today anyways, but which, just generally speaking, is it preferred to have an assignment Wednesday due Friday, then you have the weekend off, or an assignment due Friday, assigned Friday due Monday?
Yes, I'd like to focus.
What, really? You do your homework on the weekends? He's like, Dane, you don't do your homework. Period.
Fair point.
Aye. Okay, so now let's look at our output here. I'm just going to quickly copy all this. Okay. So as we go down our list of lexically analyzed tokens, we need to put these guys into a tree. How do we go about doing this? Last time we did this, we were doing it with very, very, very simple expressions, right? In fact, we only made ours work for initially one line. Then we decided that a statement is a collection of, each tree is a statement, correct? And the syntax tree is a collection of statements. Why is it fair to say that a syntax tree is a collection of statements?
Line is a statement.
What's Java? What would be a concise definition of Java?
Zero or more statements.
0 or more statements. So a Java programming, a Java program is 0 or more statements. Therefore, the tree, which is the representation of that program, would be 0 or more statements. Okay. So the question is how do we identify statements? As we look through this list, if we see an opening curly brace, is that the beginning of a statement?
Yes.
Could be. Certainly could be. In this case, it is. In this case, it is. But what if we saw the opening curly brace of an if statement? Opening curly brace of a while loop. Just kind of thinking ahead.
Collection of 0 1 would be another.
We have substatement.
Okay. So we got to think back to some of the stuff we looked at in our book with the look ahead stuff. When we saw the word if, actually I think the example was for the for loop, right? When we saw the for loop, as soon as it saw for, it created the tree structure, said, I want to match all of these next things. Does that make sense? So when we start a statement, the beginning of a statement can be one of many things for the beginning of a statement, correct? If the beginning of a statement is a curly brace, what do we expect next?
Beginning of statement.
We expect the statement to come next. So, correct, a beginning of the next statement. But a curly brace statement, a block statement, is a collection of statements. Okay? So, if we see that kind of statement, the curly brace guy, we know that the next thing to look ahead is we're going to match a statement. So it's probably going to be a recursive call. Back up, because we're saying we're calling match statement here or something like that for matching the next statement. If we matched a opening curly brace as the next token, what are we going to do? We're going to match another statement. Add it to the tree, match another statement. Okay. What if we see an int? Is that the beginning of a statement?
That's a part of the statement.
It's a type statement, isn't it? So int could be the beginning of a statement. If we see the word int, what are we expecting next?
Oh,
ID.
An identifier, followed by equal sign, followed by a literal. Or an identifier. Yep. Okay, you kind of see where we're going with this?
well, what about when they're just declaring it like in here? It's just saying
Yeah, a couple options. This is the look ahead. So you can say int I, semicolon, or you can be looking for int I equals value, semicolon, where a value is either a literal or an identifier. Does that make sense? So now we have to deal with those branches of the look ahead. Okay? What if we're dealing with a J? Just an identifier. Is an identifier a start of a statement?
Yes, could be.
Give me an example.
A equals B.
Okay. A gets B semicolon. All right, so this guy could be the beginning of a statement. So far as we're going down this list, this could be the beginning, this could be the beginning, this could be the beginning, this could be the beginning. No, this one can't.
Okay.
Semicolon can't be the beginning, right? And so at least we've ruled out one. Okay, so semicolon cannot be the beginning. Int can be, J could be, semicolon can't be, float can be. What about square bracket? Okay. Literal?
Yes. No.
I don't think a literal can be the beginning of a statement. Close square bracket? Variable? So an identifier. Semicolon, no. All right, so far we could say beginning of statements could be a curly brace, opening curly brace, So we could have a block statement, or we could have a type. Actually, it would probably be a var-def statement. var, kind of using some of our lingo from last semester. A var-def statement would begin with a type, like int or float. Okay? Or we could have an assign statement, something that began with an identifier. Or we could have a well, forget about the while statement for right now, but clearly we could have a while, we could have a for. So even though it seemed like almost anything can be a statement, they are more hit and miss. That well, they're more rare than we originally thought. We just have a lot of statements represented here. Why? Because we have sample code that represents a Java program, and Java programs are a collection of statements. Make sense? All right, so what we're going to have to do next time is we're going to have to add to our language reference the ability to identify whether a specific lexically analyzed token, is the beginning of a statement. Because if it's the beginning of a statement, what do? We start a new tree. It'll be a subtree of the bigger tree, but it's still a new tree.
It's a tree that we can make and add to.
Correct. Does that make sense? And then we'll have to add our look-ahead stuff into that. So if it's a var-def, how do we do that? Well, there's two versions of that. There is type followed by identifier followed by semicolon, or there is type followed by identifier followed by assignment operator, equal sign, followed by identifier followed by a semicolon. So two different versions of a type def. Make sense? All right, so we'll come back on Friday and pick up there. And initially, we're going to treat this as if there's only one version of a type def. Then we'll figure out what's the right way to deal with a branching expectation. Okay? All right, I'll see everybody on Friday.